Dear students and viewers, welcome to the course of Computer Networks. In this lecture, I will explain TCP IP model. Today's topic is very important because the TCP IP model is the backbone of today's internet. Let's see the contents for this presentation. First, we will see the learning outcomes, then the TCP IP architecture, and the different layers of this model. So let's see what are the objectives for this lecture. At the end of this lecture, you would be able to understand the concept of a layered architecture. You would also be able to explore the different layers or levels of the TCP protocol suite. You would also be able to learn the responsibilities of these different layers or the services that these layer provides. First, let us see why a layered architecture is important. To explain a layered architecture, let's consider an example, an analogy. How would you describe an airline system? Well, airline system is a complex system. It includes several entities like ticketing agents, baggages checkers, gate personnel, pilots, the airplane itself, the air traffic control system, and a worldwide system for routing these airplanes. Now, one way to describe this complex system is to consider the series of action that you can take when you decide to fly on an airline. So what are those actions that you would need to take? These actions are like purchasing your air ticket, checking your bags, the baggage system, go to the gate, and then eventually you will get loaded onto the plane, and the plane will take off, and then it will reroute, or it will route to the final destination. These are the things, the actions that actually happen at the source. At the destination, the same process repeat in a reverse order. For example, the plane takes off and it routes to its destination, and after your plane lands, you deplane the gates of the airplane, and then you claim your baggages, and after that, if the trip was paid, you complain about the flight to the ticket agent. So this is how you actually explain an airline system. Well, another question is that what is the analogy here of this example with the computer networks? Here you are being shipped from source to destination by using an airplane. In the computer networks, a packet is shipped from source to destination in the internet. So the airplane here is the internet, and the passenger here is the packet. So if you compare this example with the computer networks, it fit very well. Let's move forward. This is a more detailed look at the same analogy. We have noted that there is a ticketing function at each end, and there is also a baggage function for already ticket passenger at each end, and a gate function for already ticket and already baggaged passenger. And now for passengers who have made it through the gates, that is the passenger who are already ticket baggaged in and goes through the gate, there is a takeoff. That is, the passenger is now ready to take off in the plane, and while in the flight there is a routing plane, or you can say a routing function, the route that this airplane will follow. Okay, so the same things happen at the destination in a reverse order. Now let's see the layering approach that we have seen in this example. If you give attention here, you may notice that we have divided the airline functions into different layers. Like we have a layer for the tickets, we have a layer for the baggage, and we have a layer for the gates, and so on. And you also note that each layer actually implements some functions, or you may say that it offers some services. How? That is that each layer here will provide its services by performing certain actions within that layer. And also it is important to note that each layer will be using the services of the layer directly below it. Here the ticketing layer will be using the services of the baggages, and the baggage will use services of the gates, the gate will be using services of the runway takeoff, and so on. You can also say it like this, that a layer will actually provide its services to the layer above it. Okay, so this layered architecture actually present a well defined structure of a large and complex system. You can also say that a layered architecture actually provides modularity, making it much easier to change the implementation of the services provided by the layer, and while the remainder of the system will remain unchanged. For example, if the gate function here in this example, if the functions provided by this layer, if they are changed, then the remainder of the airline system would remain unchanged. So that is an advantage of the layered architecture. Now let's see why we actually need a protocol layer architecture. So for that we need to take another example, which will highlight the need for using a protocol layered architecture. In this case, the communication is simple. And when the communication is simple, we may need only one simple protocol. But when the communication is complex, we may need to divide the task between different layers, in which case we need a protocol at each layer or each protocol layer. So let's develop two simple scenarios. Scenario number one is mentioned here. In this first scenario, communication is so simple that it can occur in one layer only. Assume that we have two communicating parties, and the communicating parties here are Maria and Anne. Assume that they are neighbors with a lot of common ideas here. So communication between Maria and Anne, it take place in one layer, that is face to face, and the communication take place in the same language, and this is shown in the figure. But even in this simple scenario, we can see that a set of rules need to be followed. What are those rules? The communicating parties should greet each other when they meet. They should confine their vocabulary to the level of their friendship. And each party knows that she should refrain from speaking when the other party is speaking. At one time, only one person will be talking. And also both should have the opportunity to talk about the issue. Like conversation should not be one way. Maria should take turn in the conversation while Anne should take turn in the conversation as well. And they should exchange some nice word when the conversation is over. So these are some general rules that they need to follow while communicating with one another. However, this is a simple communication scenario. Now let's consider a second scenario, a more complex scenario. In this second scenario, suppose one of the communicating party, for example N, she decided to move to another city. Now the two friends still want to continue their communication and exchange some ideas. So for that, they decided to continue their conversation by using mail. Now they are not neighbor of one another, they cannot do the conversation face to face, so they have decided why not to make use of mail system in order to exchange ideas, in order to conversate with one another. However, they do not want their ideas, their conversation to be revealed by other people. For example, if the letters are intercepted by the third party, then that is not acceptable. So they agreed on encryption and decryption technique. This is something related with the security. I will not go into the detail of encryption and decryption, but that is a service that we actually use in order to make our communication secure. So they agree on encryption and decryption technique. Now we can say that the communication between Maria and Anne take place in three different layers. What are those layers? Suppose Maria sends the first letter to Anne. Maria talks to the machine at the third layer here, at layer number 3. The third layer machine will listen to what Maria says, and it will create a plain text. Plain text is a text that is readable without taking any security measures. And then this plain text is passed to the second layer machine. Now the second layer machine takes the plain text, and then it will convert the plain text, or you can say it will encrypt the plain text and will create the ciphertext, which is the secure text. And this ciphertext is passed to layer number 1, the first layer machine. Now the first layer machine takes the ciphertext, put it in an envelope, adds the sender and receiver addresses, and mails it, for example, through US Post. Now what happened at the end side? At the end side, the first layer machine picks up the letter from Anne's mailbox, recognize the letter from Maria. How? By reading the sender address. And then the machine takes out the ciphertext from this envelope and deliver it to the second layer machine. Now what is the responsibility of this layer? The machine at this layer take out the ciphertext from the envelope, and then the machine here will decrypt the message, and it will create, or it will derive the plain text from this ciphertext. That is the responsibility of the machine at second layer. And then it will deliver the plain text to the machine at layer number 3. Now the third layer machine takes the plain text, and it will read the plain text, and the plain text will be listened by the Anne. So this is how communication take place between these two communication parties. Now what is the role of protocol here? Protocol plays an important layer, and this protocol layered architecture actually enable us to divide a complex task into several smaller and simpler tasks. Now consider an example again. What if we use only one machine, like we are using 3 different machines at 3 different layers? What if we use one machine and the one machine will do all the tasks for us? In other words, what if we use only one layer for communication? We could have used only one machine to do the job of the 3 machines. However, in that case, for example, if Maria and Anne decided that the encryption and the decryption done by the machine is not enough to protect their privacy, their secrecy, so they could have to change the whole machine in that case. And in the present scenario, if they are using a layered architecture, what they need to do? They only need to change the functionality of layer number 2. Layer number 1 will not be affected, layer number 3 will not be affected. So that is the beauty of using a layered architecture, and that is the importance of using a layered architecture. And this is referred to as modularity. Modularity in this case means independent layers. Also, there are some other advantages of using a layered architecture. Another advantage of protocol layering is that it allows us to separate the services from the implementation. A layer needs to be able to receive a set of services from the layer below it, and it will give the services to the layer above it. We don't care about how the layer is implemented. It is just using the services of the layer below it, and it is only offering the services to the layer above it. So this is another another advantage of using a layered architecture. Now, after covering the context, let's move to the actual topic, and that is the TCP IP model, or the protocol suite. A protocol, as we know, defines the rules that both the sender and the receiver and also all the intermediate devices need to follow in order to be able to communicate effectively. This protocol model, this protocol suite, TCP/IP, which stands for Transmission Control Protocol and Internet Protocol, it was created by a group of computer scientists related with the ARPANET project, and that was covered in the history of Internet. And the goal was to create an open architecture that would allow virtually all computer networks to intercommunicate with one another. So it is actually a protocol suite. Protocol suite means a set of protocols organized in different layers that are actually used in the internet today. This is the model that is used by the internet today. It is actually a hierarchical protocol suite. The protocols are organized in different layers, and these modules actually interact with one another. So the term hierarchical means that each upper layer protocol is supported by the services provided by one or more layers below it. The original TCP/IP protocol suite you will see in some book that define 4 layers. But today, however, TCP/IP is thought to be comprised of 5 layers. And these layers are application, transport, network, data link, and physical layer. Also, these names are different in different books. Different sources use different names for defining these individual layers. Now let's consider a scenario in which a small internet is made up of 3 local area networks, and each local area network is connected with a switch. So here is an example. We will see how the layers in the TCP model or the TCP protocol suite are involved in communication between 2 hosts. We have a source A and we have a destination B, and they want to communicate with one another. Here is the scenario. We also have another node C, but we will be focusing on A and B. B is connected to this link 2, A is connected to link 1, and link 1 and link 2 are connected by a router. Suppose that computer A, which is source, communicates with computer B, which is destination. So actually in this scenario we have 5 communicating devices. What are those communicating devices? Source A, the link layer switch link 1, the router is the 3rd component, link 2, and the 5th one is the destination host computer B. Each device is involved with a set of layers depending on the role of the device in the internet. The 2 hosts are involved. You can see the 2 hosts, source A and source B, they are actually involved in all the 5 layers. On source A we have a protocol suite which comprises of 5 layers. On destination B we have a protocol suite which comprises of the 5 layers. Okay, so here the source needs to create a message in the application layer and send it down to the layers so that it is physically sent towards the destination host, and the destination host need to receive the communication at the physical layer and then deliver it through the other layers so that it reaches to the application layer. If you see at the router is involved only in 3 layers. Okay, what are those layers? Network, data link, and physical layer. So the router is involved in only 3 layers you can say there is no transport layer at the router and there is no application layer at the router, because the router is only the functionality of the router is only to route the packet. So there is no need for transport layer and no need for application layer. So on the router we have only these three layers of the protocol suite in implemented form. If you see at the link, the switches, you will notice that it involves only two layers, the bottom two layers, the data link layer and the physical layer. We do not have the network layer, we do not have the transport layer and the application layer at these switches. We will see more details later on about it, but it is a simple network scenario on which the TCP IP model is being implemented. Now here is a question: where protocols are actually implemented? To put it in other words, whether the protocols are implemented in the software like operating system, or whether it is implemented in the hardware like the router, switches, computer, etc. So the answer to this question is that the protocol layer can be implemented in either software or in hardware, or maybe it is a combination of the two. For example, later on in this course, we will see that HTTP and SMTP are almost always implemented in software in the end system. Transport layer protocols are also implemented in the software. However, the physical layer and the data link layer are responsible for communication handling over a specific link. So they are typically implemented in the network interface, a hardware interface card. For example, Ethernet, Wi-Fi interfaces, and so on. And also the network layer is often a mixed implementation of the hardware and the software. Now let's see the duties, the functions performed by the layers in the TCP IP model. As we just saw that the TCP IP model comprises of 5 layers. What are the services provided by these layers? So we are going to see the functionalities provided by these layers. Let's see this, consider this figure. Usually you can see a logical connection is established between two layers, and it is easy for us to understand the concepts. So for making it simple, you will have to think like the application layer on the source host is actually communicating with the application layer on the destination host. So there is like a logical connection directly between the application layer on one host with the application layer on the second host. And then there is a logical connection between the two transport layer, a logical connection between two network layers, a logical connection between the data link layers and the physical layer. However, the duty of the network, like here you can see that the duty of the network and the physical layer, that is a bit different from the duty of the upper three layer. How? The duty of the application and the transport layer is end to end, while the duty of the data link and the physical layer, there is actually hop to hop, because in between we have other intermediate devices. Let's see another way of explaining this. Another way of thinking of the logical connection is to think about the data unit created from each layer. You can see at the top three layers, the data units, they are actually the packets, and they should not be changed by any router or any switch. However, in the bottom two layers, the packets created by the host, by the sender, is actually changed only by the router, not by the switch. And this figure shows. Another way to think is about the different names that we are actually giving to the messages at different layers. We will see it in a moment. Messages at the application layer are known as messages. At the transport layer we call them datagram. At the network layer we call them datagram. At the data link layer we call them frame, while at the physical layer we call the messages the bits. So these are different names that are actually given to the messages at the different layers. Let's move forward. Here we have some details about the application layer. We are going to study the different layers of the TCP IP model one by one. So the first layer is the application layer. As you can see here, our first layer is the application layer. So we are going to explain each layer in detail by starting from the application layer. The application layer is where the network applications and the network application layer protocols resides. That is the first point. Application layer is a place for the network applications and the network protocols. It is also responsible for providing an interface to the application user. The user will directly use the application, which resides at the application layer. And as we saw, it is also like the logical connection between two application layers, and that connection is actually end-to-end, or you can say process to process. So communication at the application layer is between two processes, not between two systems. And what is process? Is actually program running at that computer. To communicate, a process sends a request to other process and receive a response from the other process, not from the system, because a system may run several processes at the same time. So process to process communication is the actual duty performed by the application layer. And this application layer in the TCP IP model is a place for so many predefined protocols. Later on we will see some of them in details. HTTP Hypertext Transfer Protocol is the vehicle for accessing the World Wide Web. Similarly, we do have a protocol for email. There is the SMTP, Simple Mail Transfer Protocol. This is the main protocol used in electronic mail service, and this is also an application layer protocol. For file transfer, we have FTP protocol, File Transfer Protocol, and it is used for transferring files from one host to another host. Similarly, for accessing a site remotely, we have Telnet and also SSH. SSH stands for Secure Shell, and Telnet stands for Terminal Network, and they are used for accessing a site, a system, a host remotely. We also have a management protocol at the application layer, and that is known as Simple Network Management Protocol, and this is used to manage the internet at global and local level. Another application layer protocol is called the DNS, which stands for Domain Name System, and it is used by other protocols to find the network layer address of a computer. You just need to remember that these are the protocols for the application layer, and the details will be covered later on in this course. So the application layer, in summary, it is actually the place for the network application as well as for the network protocol, and it is responsible for providing an interface to the user, and the communication, the logical connection between the two applications is end-to-end, and the communication actually happen here is process to process communication. Next layer is called the transport layer. The transport layer is also sometimes referred as host to host layer. Transport layer is responsible for many different things we will cover later on, but as a summary, the transport layer actually transports the application layer messages between applications and point. Like the application layer, the transport layer is like a logical connection which is established at the transport layers, and this connection is end-to-end. The transport layer at the source node or at the source host get the messages from the application layer, and then it will encapsulate the message in a transport layer packet, which is called segment or user datagram. You see, the message is received from the application layer. Now at the transport layer, the message is either called a datagram, or sometime it may referred to be as a segment. And after receiving this message, it sent it through a logical connection to the transport layer at the destination. So the connection here is end-to-end, like the connection of the application layer. This transport layer is also responsible for giving services to the application layer. Remember, each layer will provide services to the layer above it. So the transport layer will provide its services to the application layer, and the application layer will provide its services to the user itself. So the transport layer is responsible for giving services or providing function to the application layer. And what are those services? Actually, it will get a message from the application program running on the source host and will deliver it to the corresponding application running on the destination host. That is the basic responsibility or the service offered by the transport layer. Now here is a question: why we need end-to-end transport layer when we already have an end-to-end application layer? The simple reason for this separation is the separation of the task and duties. The transport layer should be independent of the application layer. And also more than one protocol in the transport layer is possible, which means that each application program can use the protocol that best matches its requirement. Later on, we will see that some protocol will make use of a TCP, which is the protocol at the transport layer, while some application will prefer to use another protocol which is called UDP, that is another transport layer protocol. Our third layer for the TCP IP model is called the network layer, which is also sometimes referred to as internet layer. And this is responsible for moving the network layer packets, which is known as datagram, from one host to another host. The internet transport layer protocol, as we just saw, the TCP, the UDP, in a source host passes a transport layer segment and destination address to the network layer. And then the network layer provides the services of delivering the segment to the transport layer in the destination host. So in summary, the network layer is responsible for creating a connection between a source and a destination computer. And the communication at the network layer is not end-to-end, it is host to host, and a host could be anything. However, since there can be several routers from source to destination, so the routers in the path are responsible for choosing the best route for each packet. Now the question again rises, why we need a network layer? We can also implement the duty of routing at the transport layer. So one reason for having a separate network layer is again the separation of different tasks between different layers. And there is another reason. The second reason is that the router do not need the application and the transport layer. As we saw, the router, here we have the router. It does not implement the transport layer and not the application layer. It only implements the lowest three layers of the TCP IP model. Okay, so actually it is like a separation of the services, and also we do not need the upper layers to be installed at the router. And why we are separating the tasks? Separating the tasks actually allow us to use fewer protocol on the router, because these devices are they are like restricted in resources. So we need to install fewer protocol on these intermediate devices. So the network layer in the internet include the main protocol, which is the IP protocol. At the application layer, we saw different protocol. At the transport layer, the two protocol are the TCP and the UDP, while at the network layer the main protocol, the main vehicle is the IP. Okay, it defines this IP protocol will define the format of the packet, and the packet here is called the datagram. And this IP would also be responsible for routing the packet from its source to the destination. And this is achieved by each router forwarding the datagram to the next router, next host in the path. The network layer include unicast like one-to-one, multicast like one-to-many protocols. That is, if a router receive a packet, what the router need to do with the packet, whether to forward that packet to only one host or more than one host. So a routing protocol actually does not take part in routing. It is the responsibility of the IP, but it creates forwarding tables for routers and will help them in the routing process. So the network layer actually, beside from IP protocol, it also uses some other auxiliary protocols, for example IC, MP, DHCP, ARP and other protocols, but we will not go into further details. Our next layer, the fourth layer, is known as the network access layer, or sometime data link layer, or to be more simple, link layer. Different names are there for this layer. Well, the internet network layer actually routes datagram through a series of routers between the source and destination. Now, to move a packet from one node to the next node in the route, the network layer needs to rely on the services of the data link layer, or you can say that the data link layer will offer its services to the network layer above it. Here, this layer is actually responsible, or it is concerned with access to and routing data across a network for two end systems attached to the same network. Some link layer protocols will provide reliable delivery from transmitting node over one link to receiving node. However, the reliability services is different from the reliability services provided by the TCP layer. TCP does not define any specific protocol for this data link layer. However, some of the protocols for the data link layer are Ethernet and Wi-Fi. And finally, we have the physical layer. So the physical layer is actually responsible for carrying the individual bits in a frame across the link. You can say that it is actually responsible for transmitting bits over a communication channel. So the job of the link layer was to move the entire frame from one network element to the adjacent network element. However, the job of the physical layer is to move the individual bits within the frame from one node to the next. Although this is the lowest layer in the TCP/IP protocol suite, however, the communication between two devices at the physical layer is still a logical communication, because there is another hidden layer below the physical layer, hidden layer not mentioned in the suite, but that layer is known as the transmission medium, or you can say the actual transmission medium. So the actual transmission doesn't happen at the physical layer, actually it happens at the physical media, which is below this physical layer, but that is hidden. So the two devices are connecting actually by a transmission medium, and this transmission medium can be a cable or it can be air, it can be any frequency channel. So we need to know that the transmission medium does not carry the bits, it carry electrical or optical signals. So the bits received in a frame from the data link layer are transformed and sent through the transmission medium, but we can think that the logical unit between two physical layer in two devices is a bit. There are several protocols that transmit a bit into a signal. So the physical layer, to summarize it, actually it covers the physical interface between a data transmission device and a transmission medium, And this layer is concerned with specifying the characteristics of this transmission medium, that is the hidden layer, and also the nature of the signal, the data rate, and related matters. So I will not go into further details of the physical layer, but that is actually the last layer of the TCP/IP protocol model. And below the physical layer we have the medium where the actual transmission happen in the form of signal. So that was a bit about the TCP/IP model. Thank you for watching the video. Take care and goodbye.